Okay, let's unpack this. We are diving into a technical topic that, well, it's plagued developers, designers, and frankly, every curious Windows user who's ever glanced longingly at an iPad interface.
Uh-huh.
How exactly do you get that polished, sleek iOS experience without having to drop serious cash on Apple's, proprietary hardware?
It is the classic platform exclusivity conundrum, isn't it? In the world of software development, especially mobile apps, testing your product on the iPhone and iPad platform isn't really optional.
No, it's mandatory.
It's absolutely mandatory.
Yeah.
The Apple ecosystem is massive, critical for market success. Now, if you're already operating within Macintosh, it's straightforward.
Right, you use Xcode or Apple's Dev Kit. Simple.
Simple enough.
Mhm.
But the moment you, the developer or designer, are working on Windows or, say, a Linux machine, you hit this massive operational hurdle.
It's the $1,500 roadblock, basically. You need an easy, affordable shortcut to testing and visualizing that experience when you don't own the device itself.
Or when you need to scale up testing across a huge team.
Exactly.
And that need has given rise to, well, a dizzying spectrum of tools, often categorized pretty poorly.
So today's deep dive is your definitive shortcut, hopefully, to understanding this complex world of mobile app testing and visual replication.
Our mission is pure clarity. We're going to demystify two terms that get thrown around interchangeably all the time, simulator and emulator.
And
Then we're going to zero in on one specific tool that just dominates the conversation, iPadian,
Yeah.
even though it's actually one of the most technically limited.
Right, and this is where it gets really interesting, because that technical distinction between simulation and emulation, it isn't just academic jargon.
No, not at all.
It dictates the quality of your product, your testing. We'll establish the strict definitions and explore why a tool like iPadian has achieved, well, massive popularity.
Downloaded over 10 million times, they say.
10 million times by deliberately choosing a limited role and, crucially, using that limitation as its core strength.
The challenge isn't just about running an app, you see. It's about testing app development effectively. That's a critical step, especially when you're targeting Apple's specific ecosystem.
Which relies heavily on those proprietary native application programming interfaces, the APIs.
Exactly. So our goal today is to put iPadian into context. We'll show you the professional-grade tools, the really heavy-duty stuff, and then reconcile the vast difference in approach and price.
Which means we start at the foundational level.
Yep.
Let's get our terms right. Okay, let's start with the fundamental problem. This critical need for cross-platform testing. If you're a company, you just cannot afford to ignore the iOS market.
Billions in revenue. You just can't.
Right. But your entire internal development team might run on Windows, maybe because of cost or security or just existing infrastructure.
Common scenario.
So you must be able to test and run apps developed for the Apple ecosystem, regardless of your host operating system.
Precisely. And the initial requirement for testing, it generally breaks down into two main categories.
Okay.
First, you need to check the visual layout, the graphical layer, UI, UX visualization. Does the app look right? Does the text fit? The basics.
The surface level stuff.
Yeah. Second, ensuring the underlying code, the native functions, the hardware interactions, that they all work correctly. That's the deeper level.
And these tools, simulators and emulators, they offer an accessible way to cover those requirements without having to buy stacks of iPhones and iPads.
That's the promise anyway. An easy shortcut.
So let's get into the key definitions. This is the imitation versus duplication debate. If you only retain two pieces of information from this whole deep dive, let them be these definitions.
Okay. Challenge accepted.
Walk us through the distinction. Simulator versus emulator. What's the deal?
Okay. The difference really hinges on how deeply the tool attempts to replicate the target device. Let's start with the simulator.
All right.
A simulator creates an environment that strictly imitates the configurations and the behavior of an actual iOS device.
Imitates.
Think of it like a graphical shell, a high-fidelity facade. It mimics the basic features, the look, the feel, the screen dimensions.
So it looks like an iPad on my Windows screen.
Pretty much. It runs some apps, particularly web views or simpler applications, but here's the key. It doesn't replicate the physical hardware or the kernel of the operating system.
Ah.
It's software mimicking software behavior. That's it.
So it's like a Hollywood stage set. It looks exactly like the street it's supposed to represent.
Yeah, good analogy.
But the moment you try to open the back door of a building, you realize it's just drywall and scaffolding. There's nothing behind it.
That's a perfect analogy, actually. You can interact with the visible part of the OS. You see the home screen, maybe launch a browser, check font sizes.
Visual checks?
Exactly. But if your application relies on a specific piece of hardware like the accelerometer, maybe Touch ID, or a low-level proprietary native API, the simulator just can't satisfy that request.
Because it hasn't duplicated the underlying architecture. It doesn't know what that hardware is.
Correct. It's just not there in the simulation.
Okay, so that brings us to the emulator. If the simulator is imitation, what level of duplication are we talking about here? Sounds more serious.
An emulator goes significantly deeper. It attempts to duplicate not just the software features, but also the underlying hardware of the device in question.
The actual hardware. How?
Well, it often includes a layer of code that translates the device's specific CPU architecture, in Apple's case, that's the ARM architecture, so that the host machine, typically by 86 or by 64 processor on your Windows PC, can understand and execute the instructions meant for the device's CPU.
Wow, okay. That sounds incredibly resource intensive. You're effectively running a device inside your computer.
You are. It's heavy.
Yeah.
The emulator replicates system calls, the CPU, memory management. This allows it to often run the actual operating system image, the native OS.
The real iOS.
Potentially, yes. And crucially, it supports those native APIs that rely on specific hardware features. This deep replication makes it ideal for professional debugging, deep testing.
But it needs a lot more power.
Definitely requires significantly more processing power and often more time to set up properly.
What's fascinating here is how often those terms get confused, even in developer circles sometimes.
Oh, constantly.
But for professionals, knowing which one you need is absolutely key to achieving quality testing, isn't it?
It's fundamental. If you're a designer just looking for visual confirmation, how does it look? A simulator is probably fine, quick and easy.
Right.
But if you're a senior developer, debugging how your app interacts with complex features like secure element calls or maybe complex system notifications or how it handles low-level graphics rendering.
Things that touch the core system.
Exactly. Then you absolutely require the duplication power of an emulator. No question.
That is the crux of it.
Yeah.
And the source material for today, it lists tools often broadly called simulators. But as you said, many of the top-tier solutions we'll discuss actually offer true emulation.
Yeah, or they support Android emulation as well, where, frankly, emulation is a bit more common and historically easier to achieve.
Right. For quality assurance, high-stakes development, you need that duplication power.
You do.
Which brings us back, finally, to iPadian. The distinction we just hammered out is critical. Why? Because iPadian specifically, and very deliberately, identifies itself as a simulator, not an emulator.
Correct. They are completely upfront about it.
And it leverages that limitation, that
Yeah.
reduced scope as a core strength. That's the angle.
They are completely transparent about their mission. Their goal has never been to replace a dedicated high-resource testing environment. Not at all.
So what is their aim?
Their aim is very specific: to deliver the beautiful, intuitive, and unique visual experience of the iPad interface to users on Windows, Mac OS, or Linux. That's it.
Purely the visual.
Purely, they operate as a graphical layer, maximizing visual fidelity while minimizing system overhead. It's a focused strategy.
All right, now we set the stage for the debate. Mass appeal versus technical utility. Because iPadian isn't just popular, it's kind of a global phenomenon in its own niche.
The numbers are pretty staggering.
Downloaded more than 10 million times, and they claim over 1 million daily active users. These are huge numbers for what is fundamentally just a graphical shell.
It really is.
So I'm going to champion the user experience here, the accessibility, the low barrier to entry that iPadian offers.
And I will reluctantly, but necessarily, raise the technical hurdles and the developer roadblocks inherent in a tool that strictly focuses only on that graphical layer.
Fair enough.
Those numbers might be compelling, but they arguably reflect casual curiosity more than professional necessity.
Okay, let's start with the case for iPadian. Why has it achieved this level of fame and adoption? The mission, as they state it, is strictly to deliver that beautiful, intuitive, and unique visual experience of the iPad interface.
And does it succeed?
I'd argue it does, because it delivers this visual power instantly and cheaply.
It provides the look and the feel of the interface. Yeah, without imposing those massive resource costs you get with running a full emulated OS.
Exactly. That efficiency is key to its mass appeal. For the casual user, the curious beginner, maybe the design student.
Someone just dipping their toes in.
Right. It absolutely delivers on its promise. It mimics the mobile app experience, allowing users to feel the difference, as they put it, between the iOS interface and maybe Android, all from their Windows PC.
So it imitates the appearance, design, basic features, simulates the GUI.
Yes, with a simple, user-friendly interface that mirrors the iPad home screen layout. It looks familiar right away.
And for visual professionals, designers, it actually does serve a real purpose there.
How so?
Well, for designers, it's pretty invaluable for that initial UI/UX visualization.
Right.
Before a company sinks potentially tens of thousands into native code or these complex, minute-based enterprise services,
Right.
they can instantly see how their corporate website or maybe a simple web app front end looks and behaves within an iPad-like browser environment.
So it acts as that crucial first filter for visual defects.
Exactly, which is a legitimate and time-saving initial use case.
Yeah.
Catches the obvious visual glitches quickly.
And it's not just a blank screen either. It allows access to a custom set of apps, they say over 1,000 total, pre-installed or designed to run within its simulator environment.
Including some big names.
Yeah, heavy hitters that define mobile consumption. Facebook, Spotify, TikTok, WhatsApp, Instagram. For the average person, this gives a pretty convincing illusion of using an iPad for common tasks.
Social media content consumption.
Exactly. It even provides a handy sidebar for simulated access to things like Siri, watchOS, tvOS, and the App Store interface.
But simulated is the key word there.
Absolutely. We must stress this. Those are simulated visuals only. You're not really talking to Siri or browsing the real App Store.
No. It sells the fantasy of the iOS environment effectively, creates a low-stakes sandbox for basic interaction.
And in the pricing advantage, it's just impossible to ignore when you compare it to the alternatives we'll get into later.
Yeah, the cost difference is huge.
It offers one of the best deals for simple visual simulation. A one-time fee, maybe $25. Or sometimes they have these Windows lifetime offers for like $9.99.
Which is incredibly low.
For Windows users who just want that immediate glossy iOS aesthetic without buying expensive Apple hardware, that price point is incredibly compelling. It sort of democratizes the visual experience.
Okay, now let's pivot. Let's address why that democratic access comes with a steep penalty for anyone involved in serious software development.
Uh-oh. Here comes the reality check.
Because it is strictly a simulator focused purely on the graphical layer, it has severe, unavoidable limitations. These really compromise serious development and debugging.
Bring on the technical limitations that would make a developer, throw their monitor.
Okay, first and fundamentally, it does not create a local functioning version of the iOS operating system on the Windows device. It's just not doing that.
It's just an application running on top of Windows.
Exactly. It's layering an alternative desktop environment over your current OS.
Right.
This means it lacks the necessary deep connections to the host machine that a true emulator or a native OS would have.
Got it.
Secondly, and critically, for any professional venture, it cannot access the official Apple App Store. You can't download new, real iOS apps.
That's a big one.
Huge. Nor does it support core iOS native features like iMessaging or GPS location services or direct access to those proprietary iOS APIs we mentioned.
So if I upload my native iOS app, which relies on, say, a specific core graphics function, or it needs to access the camera through a native API,
Forget it.
it's just not going to run or interact with those core OS functions I need to test. iPadian is effectively blind to them.
Correct. The focus remains purely on graphical presentation and web-based applications that run within its contained environment. It's fundamentally insufficient for deeper testing, for debugging, performance optimization.
Anything requiring real interaction with the device's actual hardware or the native iOS kernel.
Exactly. It just can't do it. Furthermore, the tool itself requires the installation of Adobe Air on the PC to run.
Ah, Adobe Air. I remember that.
Yeah, it adds another technical dependency layer that, frankly, many modern web-based tools have eliminated. It feels a bit dated in that respect.
And there is a crucial warning we absolutely must share about iPadian regarding integrity and safety, which stems directly from its viral popularity.
That's right. This is really important. The massive user base has created a ripe target for malicious repackaging.
Meaning?
The official iPadian company stresses that iPadian is commercial software sold directly via its official website. They are very clear. Users must strictly avoid unauthorized free versions found elsewhere.
Torrent sites, shady download aggregators.
Exactly those places. Because what's the danger in getting a free copy of something so popular?
I suspect it's not really free.
The danger is significant. Our sources warn that unauthorized third parties often repackage these files, embedding them with harmful payloads.
Like what?
Those illegitimate downloads may contain persistent adware, incredibly annoying pop-ups, or even full-blown malware, ransomware, spyware, you name it.
Yikes.
The official software, purchased from iPadian, is clean and ad-free. They maintain it to protect their commercial reputation. But the moment you chase a cracked version, you are absolutely rolling the dice on your system's security.
And the vigilance required here is high, especially because the product is designed for a mass audience, often people who aren't super technically savvy.
Precisely the target for that kind of malware distribution.
Okay, so iPadian. The definitive choice for the visual designer, maybe the marketing team, the curious beginner, who wants the look and feel for a very low cost.
Right.
But it's entirely inadequate for the professional who needs to deeply test and debug native code.
That sums it up well.
That creates the perfect niche for it to become famous, because its core product, that visual aesthetic, is what millions of casual users prioritize.
It solved the visual access problem while neatly sidestepping the far more complicated and expensive technical emulation problem. It's actually a brilliant market-driven compromise when you think about it.
Okay, so to truly understand iPadian's specific niche and the compromises baked into its design, we have to compare it to the professional-grade options.
Yeah, the tool's operating on a completely different scale. Complexity, resource management, and definitely cost.
We are moving from potentially a $9.99 lifetime visual skin to tools costing thousands of dollars per month. It's a huge leap.
The contrast is jarring, absolutely. But it illuminates what true emulation and real enterprise features actually cost. We should start with cloud-based emulation, which represents, arguably, the highest tier of flexibility and scale right now. Hashtag tag 3.1 cloud-based emulation and enterprise solutions.
Let's start with the heavyweight champion of web-based testing, Appetize.io, often cited as the best emulator simulator for many enterprise developers.
It certainly comes with an enterprise price tag to match that reputation.
So what makes it so powerful? Why is it the go-to for big companies?
Appetize is defined by its versatility and scale, particularly its web-based delivery model. It's a full-fledged iOS simulator and Android emulator.
Both platforms.
Both. And you run the apps directly within a web browser, usually streaming the device screen via HTML, maybe an iframe structure. The core benefit, zero installation for the end user.
Right. The device image, the OS environment, it's all hosted on their cloud servers.
Exactly. The convenience of not needing to download anything, being able to access a functioning device image from any browser, anywhere, that's a massive feature for large distributed teams.
But let's talk about the why of the enterprise adoption. Why are companies like Shopify or Intuit trusting them with testing? It must be more than just convenience.
Oh, much more. It allows for streaming your app instantly to any device globally with guaranteed performance. Its use cases go far beyond just internal development testing.
Like what?
Well, this solution is heavily utilized for things like large-scale training purposes, for customer support, and for business demos. Think about support. Large corporate call centers can use its remote device viewing feature to diagnose customer problems in real time and provide support directly on a virtual device.
So the agent sees exactly what the customer is seeing.
Precisely. And crucially, this ensures every agent is looking at the exact latest version of the app running on a standardized, pre-configured device image. It eliminates so much guesswork.
That seems like a massive reduction in variability and support time. But you also mentioned specialized enterprise features like service-level agreements and white labeling. For the listener who isn't deep in enterprise IT, what do those mean in the context of a, say, $2,000 a month service?
Right. Service-level agreements, SLAs, are critical guarantees. They promise specific levels of uptime, response time, and performance.
So the service will actually work when you need it?
Essentially, yes.
Yeah.
For an enterprise handling high-value transactions or operating in a regulated industry, if their testing or support portal goes down, the financial damage can be catastrophic. And SLA ensures Appetize.io commits contractually to minimal downtime, often guaranteeing 99.9%, sometimes even higher availability.
And there are penalties if they fail.
Usually, yes. Significant financial penalties. That legal certainty and reliability is a huge part of what you're paying for at the high end.
Makes sense. And white label capabilities. I assume that means companies can brand the service as their own.
Exactly that. For their enterprise clients, White labeling allows them to fully integrate the Appetize streaming solution into their own corporate infrastructure and branding.
So the end user doesn't see appetize.io.
Correct. Whether they're a developer, a support agent, or a beta tester, they see a testing portal branded entirely with the company's logo, colors, integrated with their single sign-on. It makes the integration seamless and professional, which is crucial for corporate infrastructure and security policies.
Okay, so they're selling time, scale, global access, and that enterprise-level reliability. But let's talk about that jaw-dropping price structure again. The free trial is severely limited, 100 minutes a month, basically nothing.
Barely enough to kick the tires.
The basic plan starts at $40 per month for 500 included minutes. Still not a lot for a team. But the enterprise clients, the ones getting the SLAs and white labeling, can climb up to $2,000 per month for unlimited usage.
It is a universal way from the $9.99 lifetime fee of iPadian, isn't it?
Absolutely. How do they justify that cost? Where's the return on investment?
The justification comes down to ROI in highly sensitive or large-scale environments. If a pharmaceutical company needs to test a regulated app on dozens of specific iOS versions and device configurations and retain audit logs of every single test session for compliance.
Okay, I see.
Or if a global financial institution needs 247 reliable access for thousands of support agents worldwide, the minute-based billing, or the unlimited plan, starts to make sense. They're paying for instant provisioning of a fully licensed, dedicated, and auditable virtual device.
Which would cost exponentially more in physical hardware, management overhead, space, power.
Exactly. The total cost of ownership for a physical device farm is enormous.
But isn't $2,000 a month still ridiculous overkill if all I need is visual testing, if I just want to see if my button is aligned?
Oh, absolutely. They don't justify it for simple visual alignment. Their target market isn't looking for an iPadian replacement. They're looking for a replacement for a physical device farm, a global support infrastructure, a development tool that integrates deep diagnostic testing in the cloud.
Right.
Appetize is built for load testing, continuous integration pipelines, massive real-time collaboration. It's selling a solution to manage scale, security, and compliance, not just a screen image.
That puts the pricing into much sharper perspective. Okay, moving on, we have SmartFace. This one emphasizes a different angle, the single code base philosophy.
SmartFace is a fascinating technical paradigm shift, actually. It's designed for cross-platform depth, working for both iOS and Android apps. But its key technological selling point is its ability to support native iOS code development and compilation.
Without needing a Mac.
Without requiring a Mac build host connected.
Native iOS code on a pure Windows machine. That's significant. That breaks one of Apple's fundamental ecosystem rules, doesn't it? How do they even achieve that?
Well, they utilize a sophisticated abstraction and compilation layer. It translates the native code often written by the developer in JavaScript or a similar high-level language into truly native binaries for both iOS and Android.
So they essentially bypass the traditional need for Xcode's compilation process on a Mac.
They've effectively built their own environment to do it.
Okay.
This enables high-performance, genuinely native results from a single source code project, regardless of the host OS, Windows, Linux, Chrome OS, Mac OS.
That simplifies development and management immensely for teams needing to deploy quickly across both major mobile platforms. One code base to rule them all.
Absolutely. And for development, it includes a YG design editor.
Right, what you see is what you get.
Exactly. It provides an intuitive visual editor where developers can design the interface by dragging and dropping elements, and the underlying code is auto-generated in the background. Speeds things up dramatically.
Availability, cost.
It supports Windows, Linux, Chrome OS, and Mac OS. The entry price starts around $99 per month, but you have to request a demo first.
Ah, the request a demo gate.
Yeah, it signals their focus on professional, committed users, not casual browsers.
Okay. Next, let's pivot to a tool focused more on collaboration. Run That app. This one apparently has a truly unique feature for troubleshooting efficiency.
Run That app is also about hosting your app anywhere, accessible via browser, much like Appetize. But its primary strength is collaborative, real-time app interaction.
How does that work?
It allows the support person and the customer who might be experiencing a bug to interact with the exact same running instance of the app simultaneously in real time.
Wow, so they're both clicking around in the same session.
Potentially, yes. Or one is observing while the other demonstrates. That real-time shared interaction is huge for reducing support time and eliminating that, okay, now what did you just click? Confusion.
Yeah, I can see that. Ensures both parties are observing the exact same issue, the same state, the same error message.
Precisely. Imagine a customer hits a crash after a sequence of 6 complicated steps. Instead of trying to get them to replicate it over the phone, which is often frustrating,
Nightmare.
the support agent can join the live session, observe the exact steps the customer took, and maybe even take control to diagnose environment settings or try a different path. It's perfect for minimizing time spent on troubleshooting.
And probably great for collaborative beta testing, too.
Yeah.
Immediate feedback, direct observation.
Highly effective for that, yes.
Yeah, I was shocked to see this service is billed by the second, charged at 0.5 to a minute, which is $3 an hour. That usage-based model suggests their value prop is ultra-quick, efficient problem-solving, not long-term development cycles.
That's the perfect observation. Billing by the second or minute emphasizes their focus on efficiency. You don't pay for idle time, only for active troubleshooting or demonstration sessions.
So it's flexible.
Highly flexible and cost-effective for organizations that need intermittent, high-quality support sessions, but don't need the massive, continuous integration infrastructure of an Appetize.io. Different needs, different pricing models, hashtag tag 3.2 Apple-specific, and development-focused tools.
All right, now we dive into the core Apple ecosystem itself, where the professional tools are inherently tied to Apple's hardware and their whole development philosophy. Starting with the gold standard. If you own a Mac, Xcode.
Xcode is Apple's own integrated development environment, their IDE. It's the comprehensive official suite for building, testing, optimizing, and submitting apps for the entire Apple ecosystem.
iPhone, Watch, Mac, Apple TV, the works.
Everything. And it comes with a built-in iOS simulator that is technically far superior to something like iPadian because it's deeply integrated with the actual macOS kernel. It understands the system better.
The sources highlight its advanced features. We should expand on the practical benefits. For instance, predictive code completion. How does that actually save a developer significant time?
Well, predictive code completion isn't just basic auto-typing. It's an intelligent system within Xcode that analyzes your code context and language structure, Swift or Objective-C.
Okay.
It then predicts the full classes, methods, variables you're likely trying to use, offering accurate suggestions. This drastically reduces syntax errors, speeds up the actual typing, and minimizes the need to constantly look up documentation or remember exact names.
Less friction in coding.
Much less. Furthermore, features like interactive previews allow designers and developers to visualize UI changes in real time directly in the editor, without needing to compile and run the full application on the simulator or a device.
That saves huge amounts of compilation time, especially on large projects.
Immense amounts. It also includes built-in Git integration for version control, which is standard now, and seamless deployment integration with TestFlight and the App Store.
Speaking of TestFlight, that's Apple's beta testing platform, right?
TestFlight is Apple's proprietary platform, yes. It's for distributing beta versions of iOS, tvOS, watchOS apps to testers before they hit the store. It's pretty much the essential final step before App Store submission for handling complex, native projects and getting real-world feedback.
But the limitation is fundamental. Xcode and its simulator work only on a Mac.
Correct. And the included Safari browser, often needed for testing web components within apps, is also only available on Mac. You simply cannot use Xcode for full native development if your hardware is strictly Windows or Linux. Full stop.
But if you are a Windows developer working on a Mac-required project, there are ways to bridge that gap. We mentioned Xamarin and TestFlight earlier.
Right. Xamarin and TestFlight, which is now primarily integrated with Microsoft's Visual Studio, is Apple certified. It's arguably the best tool for handling beta deployment and testing from Windows.
How does it work?
It allows developers using Visual Studio on Windows to test their iOS apps by connecting remotely to a Mac that acts as a build server. It handles things like creating provisioning profiles and allows for the simulation of crucial app states.
Like shaking the device or rotating it.
Exactly. Simulating shake, rotation, various memory warnings, things vital for robustness testing that a simple visual simulator wouldn't handle.
And for a company managing a large testing effort, the distribution features seem key. It allows testing up to 100 apps, internally or externally.
Correct. And crucially, it provides detailed feedback collection directly through the TestFlight app itself. Testers can easily report bugs or crashes, streamlining that pre-release bug squashing process.
The caveat again, though.
The primary caveat is that the setup is technically complex. You're bridging two separate operating systems, build processes, dealing with Apple certificates. It can be tricky.
And it doesn't support older iOS versions.
Generally targets modern versions, doesn't support applications below iOS 8.0. So definitely a high-end, contemporary professional tool.
This leads perfectly to the explicit technical bridge built by Microsoft themselves, the remoted iOS simulator for Windows PC. Sounds like the perfect answer, finally, to the Windows Mac conflict. But there's always an asterisk, isn't there?
There is indeed a massive asterisk. Yes, this is the explicit solution offered by Microsoft, bundled automatically with Xamarin and .NET MAUI development workloads in Visual Studio. It allows the developer to debug iOS and tvOS projects using their powerful Windows device and familiar IDE.
Sounds great so far. What's the catch?
The catch? The massive asterisks, the crucial complexity? It still requires pairing Visual Studio with a networked Mac build host.
Okay, we need to spend a moment explaining this architecture. Why is a Mac still required? How is the workload actually split between the Windows PC and the Mac?
The Mac is still required because of Apple's licensing and security models. They mandate that only Macos can perform the final compilation and code signing steps to create a valid, executable native iOS app.
Ah, so the Mac does the actual building.
Correct. The Mac acts as the build host. It performs the heavy lifting, compiling the Swift Objective-C code, linking against the native iOS libraries, code signing, and actually executing the core logic within a simulated environment.
So what does the Windows machine do with the remoted simulator?
The Windows machine, running the remoted simulator window, receives a stream of the UI/UX visualization remotely from the Mac. The interactions you make on the Windows simulator tasks, swipes are sent back to the Mac for processing. The Windows PC essentially acts as a powerful, interactive remote display for the simulation running on the Mac.
So the Windows developer gets the convenience of using their familiar IDE, their debugging tools, their powerful hardware.
Right.
But the legal and technical necessity of the Mac is still quietly humming away on the network somewhere, handling the core execution.
Exactly. It's an elegant workflow solution, it's a great bridge, but it's not hardware emancipation from Apple. You still need that Mac involved.
It does add value, though, mimicking specific hardware like Touch ID.
Yes, it adds significant value by mimicking Apple's specific hardware functionality, like simulating Touch ID authentication flows. And it allows developers to simulate static and moving conditions, like simulating the device being still, walking, or driving, which is essential for testing GPS-aware applications without actually leaving your desk.
Okay, we've covered the professional tools, the collaborative ones, the bridging solutions. Let's look at the outer edges of the spectrum now, starting with the highest end security option. Corellium. This sounds like where we leave generalized testing and enter deep vulnerability research.
Corellium is definitely in a different league. It's designed almost exclusively for security experts, government agencies, and enterprises with the absolute deepest security concerns.
What does it actually do?
It offers a fully virtualized iOS environment, often running directly on ARM hardware or through advanced virtualization techniques accessible via a browser or API. Its function is to allow experts to test mobile apps, firmware, and even underlying hardware configurations in a secure, isolated sandbox. Think of it as a digital prison for potentially dangerous code, allowing deep inspection.
You called it military grade earlier. That's a strong term. This isn't for checking if your button is green, clearly. How do they justify that designation? What makes it so powerful for security?
It's justified by its deep integration with serious security analysis tools. This is where we need to define some jargon for listeners. Corellium integrates seamlessly with standard debuggers like GDB.
GDB.
GDB is the GNU debugger. It's a powerful command line tool used for analyzing exactly what a program is doing during execution, stepping through code, examining memory, registers, very low level.
Okay.
It also integrates with tools like IDA, the interactive disassembler. IDA is the industry standard for binary analysis and reverse engineering, breaking down compiled application code back into a more readable assembly format to understand its structure and find vulnerabilities.
That is heavy-duty analysis. We're talking about taking compiled apps apart.
Absolutely.
Right.
Furthermore, Corellium allows the use of network interception proxies like Burp Suite or Charles Proxy. These tools sit between the virtual device and the internet, letting a security researcher monitor, intercept, and even modify every single byte of data leaving the virtual iOS device.
So you can see exactly what data an app is sending, where it's sending it, and if it's secure.
Precisely. You can debug memory corruption issues, analyze encrypted traffic, find deep-seated vulnerabilities in the app or even the OS itself that a standard simulator or even emulator would never expose. You're paying for secure, granular control at the deepest levels necessary for high-stakes vulnerability research.
Got it. Now let's swing to the complete opposite end of the spectrum to wrap up this landscape view. AIR iPhone. We should mention it briefly, maybe just to contextualize iPadian's relative technical superiority.
Yeah, AR iPhone represents pretty much the lowest possible bar. It's free, which is its only virtue, and it runs using Adobe Air that same framework iPadian requires,
But
but it is fatally flawed for any serious use today. It's severely outdated. The interface looks more like iOS 3 from, what, over a decade ago?
patient history in tech terms.
And it only reproduces the graphical user interface, just the look.
And the source is explicitly warned. AR iPhone will not actually run real iOS apps as if they were natively installed. It's entirely useless for debugging or any real testing.
It's basically a historical relic at this point. It only shows you what the iPhone home screen used to look like. If iPadian is a lightweight, reasonably effective visual check for modern iOS.
Then AR iPhone is like a low-resolution, static screenshot from the distant past.
Exactly. We mention it only to emphasize that iPadian, despite all its technical limitations we discussed, was and is a massive leap forward in delivering a high-fidelity visual experience compared to its free, defunct predecessors, like AR iPhone.
So the spectrum is truly vast then, from a free, essentially useless GUI from the past, all the way up to a multi-$1,000 a month enterprise security sandbox with iPadian sitting right there at that interesting intersection of mass market curiosity and affordable visual access.
Okay, so we've established that iPadian is limited. It can't access the native app store, doesn't support iMessaging, can't run native APIs.
Right. A professional developer cannot rely on it for serious production-ready code testing. We've made that clear.
Yet, it has 10 million downloads, over 1 million daily users, allegedly. This is the moment where we have to reconcile this famous flawed tool with its actual and arguably significant utility.
And the reconciliation, I think, lies in understanding that iPadian's limitations aren't accidental flaws. They're deliberate, even shrewd design choices targeting a very specific market need.
Exactly. By being strictly a simulator and refusing to even attempt full resource-hungry emulation, it avoids all that complex overhead. It avoids the performance drains, the deep system permissions required by a full OS emulator.
It prioritized efficiency, simplicity, low barrier to entry.
And that became its competitive edge, its genius in a way. It chose its niche perfectly.
It successfully acts as that bridge, that lightweight, accessible window into the iPad user interface, specifically for casual users and designers outside the Apple hardware ecosystem.
It successfully tore down the hardware wall, but only for the visual aesthetic.
And that aesthetic, it turns out, is a product unto itself. For a non-technical user, or maybe for a marketing department that just needs to quickly approve the visual presentation of a product or a campaign running in a simple web view.
iPadian is often the definitive specialized choice. It's quick, it's cheap, it looks right.
It fulfills that crucial role we mentioned, being the first filter for visual defects before you sink resources into more complex, expensive tools like Appetize or full native development on Xcode.
It does that job well.
So if we synthesize this vast spectrum of tools into a final verdict, it really comes down entirely to matching the tool to the required depth of testing you need. But we also have to look at the overlaps and the strategic trade-offs.
Right. So for the professional developer needing full debugging power, access to all the native APIs, deep performance analysis.
The serious stuff.
The serious stuff. A tool like Xcode, if you have a Mac, or maybe Xamarin Test Flight, for Windows-based beta testing, still requiring that Mac build host, is absolutely essential. These are the tools that handle core OS functionality and native compilation properly.
Okay. Then for enterprise-level testing, large-scale collaboration, maybe global training programs, running secure web-based apps at massive scale with guaranteed SLAs and audit logs.
That's where Appetize.io comes in. It's the powerful but yes, expensive web-based solution. It's selling reliability, availability, and manageability at scale.
And this raises that crucial point of nuance we touched on. Why might a small professional team choose a mid-tier tool like SmartFace instead of the super expensive Appetize?
Well, because SmartFace offers that unique pathway to native performance on both iOS and Android from a single code base, potentially running on a Windows machine without a Mac build host.
Right, that single code base advantage.
It eliminates the need for dual development environments and avoids the continuous minute-based billing of a cloud streaming service if you don't need that level of scale or those enterprise features.
Yeah.
It's a strategic choice focused on cross-platform development efficiency.
Okay. And finally, wrapping it up. For the casual user, the curious beginner, the designer who just needs instant, affordable, visually confirmation of the iOS aesthetic.
iPadian remains the definitive, specialized choice in that niche. Its fame is a direct result of it solving the visual problem cheaply and effectively, even if it completely ignores the complex underlying technical problem of true emulation.
It's the perfect example of a product succeeding wildly by focusing laser-like on what the mass market actually wants, the look and the feel.
Rather than what the smaller group of professional developers needs, which is that deep underlying code integrity and hardware access. It knew its audience. Hashtag tagged outro.
So we have navigated the subtle but I think vital distinction between simulating behavior and truly emulating hardware. And we've seen the extraordinary range of tools available from those free, basically defunct GUI programs of the past.
Right up to the thousands of dollars per month enterprise systems used for deep security and vulnerability research. It's a huge spectrum.
The key takeaway for you, the listener perhaps, is that tools like iPadian really prove that a high-fidelity visual experience can be a compelling product entirely unto itself.
Yeah, its popularity demonstrates that for millions of users, the interface, the way it looks and feels, is the primary draw, often regardless of the underlying hardware limitations or the app's true native performance.
This really raises an important question, I think, for the future of application development. If the goal of the vast majority of modern apps, let's be honest, is often limited to just consuming content or interacting with a simple web view embedded inside a social media shell,
Which many apps are, essentially.
does iPadian's massive success, its intense focus on just interface accessibility, does it signal a future where that hardware wall truly starts to crumble, at least in terms of user perception?
Does this mean that the visual aesthetic and the consistent user experience of an operating system become fundamentally more important than the actual capability of the native hardware code? For the average user, at least.
If the user primarily cares about the look and the familiar feel, what does that imply for how deeply developers really need to engage with complex, proprietary native APIs going forward for mass market apps?
It's definitely something for you to mull over as you explore these powerful and sometimes deceptive testing shortcuts. Does the surface become more important than the substance for the majority?
Indeed. Go forth and simulate responsibly, everyone.